Hey guys, so I wanted to create a video for you guys about graphing piecewise functions. And I had a lot of really good feedback today and a lot of really good questions that I hopefully can incorporate in this video so that any questions that you have will hopefully be covered because I just had so many questions today. So this was the worksheet that I used in my standard class. So if you're in my honors class, your worksheet is slightly different. It's a little bit more complicated for you, but you will also benefit from these explanations and you should be fine. So in the middle of these two examples that I have here, I have gone ahead and written some instructions, and I strongly recommend that you take a moment and maybe pause the video and just go ahead and write these down because they're going to be extremely helpful as you go through this particular section. Is it required that you write it down? No, but it is, again, it's just beneficial. So for number 10, to get started, I'm going to just go step by step. Before I do that, though, I'm going to color code things just so that it's easier for me to explain, which problem or which number I'm working on. And the other thing that I want to do is I just want to point out really quickly that I'm going to be referring to equations, which are typically the beginning of my piecewise function. These are my equations. So like this is an equation and this is an equation. And then the other thing I'm going to talk about are constraints. These are limitations that we have imposed on our graphs, essentially. So for example, if I were to graph negative 4x, the equation negative 4x like normal, then I could do it like I learned in Algebra 1, where we had the y equals, mx plus b format, right? And this would be negative 4x plus 0. So I would have a y-intercept of 0. I would go down 4, 1, 2, 3, 4, and I would go over to the right 1, and I could draw this picture, right? I could connect my dots and fill everything in. But because I have put constraints on my function here, it says that I do not want to have the graph if it is bigger than x. It says it only wants to look at it if x is less than or equal to 0. And that's going to be from here to here on the negative side. So really this extra piece on the right, I can erase. So that's one way you can think about it. But as I said, I do have these step-by-step instructions. So I'm going to go through those steps. So you don't have to draw a bunch of lines and erase a whole bunch of things. You can just follow these steps and hopefully you'll get the right answer and you don't have to worry about it too much. So step number 1, you guys are going to draw your constraints as a dotted line. And remember, the constraint is going to be over here and it is represented by the number 0 in this case. On the other one, it would be like a 2. So another thing to really sort of note, and I wrote it in red, is that you need to use every number you see with the inequalities or with the constraints. So in these two examples, I only have constraints on my 0. So I'm going to go ahead and draw that as a dotted line. And I'm going to keep all my constraints red so that you can sort of have that as reference. Okay, so then the next thing I need to do is I need to create XY charts for each equation. Now remember, the equations are limited to a side of the constraint line I just drew. And so if I look at the first one, my green one, it's negative 4x if x is less than or equal to 0. Well, all the numbers that are less than 0 are on the left-hand side. So it would be over here. I would fill in this area, right? Another way you can sort of think about it is like the inequality is pointing to the left. So our information, the negative 4x, the equation, should be on the left-hand side of our constraint line. So it doesn't really matter to me how you think about it, but just know that your information should fill in this area here. So I have that, and now I'm going to do an XY chart. And on the little note that I put for this one says start with the number in the constraint. So my constraint number is 0, so I'm going to start with 0. And then I'm just going to ask myself, what is another number? And if you want, you can, instead of putting that negative 4x, maybe put the constraint x is less than or equal to 0. What is another number less than 0? Well, the next number would be negative 1. And you could pick something bigger if you wanted to, but in this particular case, I'm just trying to keep my numbers as small as possible. So I'm going to just pick the next one. So this is going to be negative 4 times 0. Remember, we're using that equation. And that gives me 0. And this will be negative 4 times 1, which is negative 4. Okay, so, negative 4 times negative 0, which is a positive, my bad, which is a positive 4. All right, that makes more sense. And I'm going to, I'll go ahead and jump to step 3, which is to plot my points. So my point should be at 0, 0, as well as negative 1, and then positive 4, which should be here. So I'm going to connect my dots, and this is just like before. And notice, like, this is the only portion I needed. Remember at the beginning when I drew the whole line and I erased the part I didn't need? Well, by doing this method, I only focus on the part that I do need. So I have drawn this, and the last thing I'm going to do is just make sure that I have either an open dot or a solid dot on the constraint line. So you base that off of your inequality. Remember that if you have that equal to portion underneath, it's going to be a solid dot. And if it does not have that equal to portion, it's going to be an open dot. So just make sure you have that as a note, because I have that equal to line. I'm going to go ahead and just make this a very obvious filled in dot at this point on the constraint line. You don't want to put it off to the left or anywhere else on the constraint line, because then you will get points taken off because you are not graphing it correctly. So now that I'm done with the left-hand side, now I'm going to do the right-hand side. It's the same process as before. I'm going to do a little XY chart, right? And it's purple. And if you want, you can put your constraint when x is greater than 0. So I'm going to start with my constraint number. And then the next number up that's bigger than 0 is 1. So I'm going to have 0 and then 1. And there is actually no x value for me to plug in here. So my answer is just going to be 4 for both of these. So I have an ordered pair, and that's why we do these XY charts. It tells us where to plot these points. I have an ordered pair at 0, 4, which will be here. And then I have a point at 1, 4, which is right next to it. So an important thing to note here is that when you're drawing this, you don't want to just connect your dots and be done with it. You want to make sure that you fill in that entire side that you're on. So I am actually going to extend it all the way over. I typically use like a envelope or a piece of paper or like a ruler to sort of help me, but I connect my dots and then I just follow it along, and I just draw my little arrowhead to represent that this is a ray and it's continuing on forever to the right. And then the last thing is just make sure you have a open dot, because this is going to be a greater than, and there's no equal to. So I just make it super obvious. Yes, I see that little portion in the middle. If you are OCD, you can put a little eraser and erase that so you can see it's an open dot, but it's not necessary. I am not super picky. As long as you make it obvious, I'm happy. All right, so let's do the next one just to make sure that we've got this. It doesn't have the coordinate plane filled in, so you can actually sort of draw it however you want. I'm afraid my numbers are going to be really big, so I'm actually going to lower my y-axis a little bit in hopes that everything will stay on my graph. So here's my coordinate plane, and let's go through our steps. So step 1, draw your constraints as a dotted line. Okay, so these are my constraints. I only see one number, and it's at a 2. So I'm going to put my dotted line at 2. Step number 2, create your XY charts for each of your equations. So I'm going to start with the first one. I'm going to highlight it green, and I'm going to say, I'm going to write my constraint, y is less than 2, and x, y, and it says start with the number in the constraint. Okay, so the first number I see is 2. Now I need to pick another number that's less than 2. So we could pick 1. You could also pick 0, you could pick negative 2, you can pick whatever you want, but again, I'm just trying to keep my numbers as small as possible. All right, so this is going to be 4 minus 2, which is 2, and then 4 minus 1, which is 3. So I'm going to plot my points. I've got 2, 2, which is here, and 1, 3, which is here. Okay, so again, I'm going to take my ruler because I want to fill in the entire area over here. I don't want to just connect my dots like this and be like, I'm done. No, I want to fill it all up. So I'm going to take my ruler, and it's going to look something like this. Okay, and then now I'm going to double check what type of dot it is. It does not have that equal to portion, so it's going to be an open dot. So I'm just going to make it super obvious. This is an open dot. Okay. Now I'm ready for my second equation, x plus 3, if x is greater than or equal to 2. Okay, so I'm going to write my constraint. And remember, when you're doing this, the previous problem, it just so happened that my constraint was at 0. And so it looked like it was just to the left of the y-axis, and the other one was to the right. And this one, our constraint is actually a positive 2. So some issues that I've had today is that people have been thinking that they're not allowed to go beyond the 0, and it's not based off of that. It's based off of this number here, not the origin, not the y-axis. It's just based off of whatever number they give you, and they're going to change the number almost every time. Some other issues that I've had is that when they're picking their constraint numbers down here in the XY chart, they are sometimes picking numbers beyond, and they're like drawing their line past the constraint. I want you to think about this wall as this constraint line as being a wall. You're not actually allowed to cross it. So that's why we go all the way to it and then we stop. And we don't want to put like the arrowhead facing this way, because that would again mean we would keep going, and that crosses our constraint. So we just put it on the other side, and this is a ray. Okay, so now that we've sort of hopefully clarified any of those questions up, we can get started on that x plus 3. I'm going to put my constraint, which is x has to be greater than or equal to 2, and it's going to be xy. I start with the constraint number 2, and then another number that's bigger than that is 3. So this will be 2 times 3, 2 plus 3, which is 5, and then 3 plus 3, which is 6. All right, so I'm going to go ahead and plot these points. I've got a point at 2, 5, so it's going to be 1, 2, 1, 2, 3, 4, 5. So I'm going to put a point here. 1, 2, 3, 4, 5. There we go. And then the next one is going to be 3, 6, so it's going to be right here. Okay, and then I can connect my dots, and it's not too much to fill in, and then I have a equal to part, which means that this dot I put on the constraint line. Remember, we're not going to put it over here in this space. We are going to put it on the red line, but it should be filled in completely. Okay, and so now we have completely graphed these two problems. So let's do two more that instead of just having two equations, we actually have 3. Okay, so we have completely have new problems now, and again we have 3 pieces of information, and it's going to just take more organization to do this. When we draw our coordinate plane for this one, I strongly recommend that you sort of draw your xy, your y in the center, but your x slightly raised. That's what I recommend for this one, so that you're not running into just dead space and you're going to stay on the graph. All right, so let's start with that first one. We have 2x if x is less than -2. So that's my first constraint. Remember, the constraints are whatever is with your inequality. That's these numbers over here. And I actually have 2 -2's. Not that we have to do anything special with that, but I'm going to go ahead and draw my constraint line on -2. But then I also have 2 +2's, so I'm going to go ahead and fill that in too. Now, if you're in my honors class, there are a couple of problems where you put your constraints and there's absolutely nothing that's going to be on the right-hand side, but you will not have to, but standard does not have to do that. You're going to have something for each side. All right, so I have my first one highlighted, so I'm going to go ahead and get that one started. This one says if it's less than 2, and remember, we have an arrow pointing to the left, so it's going to fill in this area here. And then if I do my next one, I have this -2 when x is greater than 2. That's pointing to the right, so that's going to be this area, the right. So you can sort of see it's sort of intuitive. The last one is going to be, and I'll make this one blue. The last one is in the middle, so you guessed it, it's got to be in the middle. And remember, it's not in the middle of just like this is where our y value is, or our y-axis, I should say. But this is the equation that should be in the section, in the center section. And the sections are separated by the constraints. And I cannot emphasize that enough because I've had a lot of questions about, like, how do we know we put our dotted lines here as opposed to elsewhere? Well, it's based off of those constraints, okay? So now it's time to get started on graphing these. So we need to go to step 2, which is create XY chart for each equation. So I'll do 2x first. 2x when x is less than -2, and I'm just putting that constraint so I can help myself figure out what numbers to pick for the x values here. Some classes I did 2 of them, sometimes I did 3. As long as you have 2, you should be fine. 2 values, not like the number 2. But in this case, I actually have to start with my -2, and then a number that is less than -2 is -3. So I'll fill that into my equation. It's 2 times x, or 2 times -2, which is -4, and then 2 times -3, which is -6. So it's time to plot these. I have, I'll go ahead and sort of show you. I have -2, and then -1, 2, 3, and 4. So I should have a point here. And then -3, 6. So if this is 4, this would be 5, 6. So I should have a point here. Okay, and I connect my dots. And again, I'm not extending over this way because I'm not in that section. You should only be filling in that 2x information, that 2x line, on the left-hand side. So I have this filled in, and it is does not have that equal to portion, so I should have a big open dot here. Okay, now I can do my other piece. Let me change my color. It's just 2, so this is between -2 and 2. I create my little XY chart. You can do there's 5 numbers you can use. You can use -2, you can use +2, you can use 0, you can use 1. It doesn't really matter what you use because in this particular case, everything's actually going to equal 2. Yeah, because there's no x value to plug in for it. Like, usually we have an x here and we can plug in and multiply, but we don't have any x value to fill in. So it's just going to be an answer of 2. So if you want, you can put all 4 of these points that I found. We have one at -2, +2, +2, +2, 0, 2, and then 1, 2. So we can sort of see this is just a flat line. But even if we didn't have those extra lines, once you have 2, you can take your ruler and just connect the dots and make sure you fill in the area. And thankfully my 2 points actually filled in my area in this case. So I have both of these done. And now I'm just gonna double check. Some questions that I had today is like, how do you know when you have 2 things like this? How do you know if you have like an open dot or a closed dot? Because we have both cases here. Like, we have a less than or equal to, and then we just have like a normal less than. Well, if you notice, the less than or equal to is with the -2. So on the -2 line, which is here, right? On the -2 line, I'm gonna make sure that this is a solid dot. And then on the +2, it's just less than, which is an open dot. So I'm just gonna make an open dot here. And again, I'm just making it super obvious. If you're OCD, you can just, erase the middle, whatever helps you with your life. Okay, so now I'm done with this one, and I can continue with the last one, which is my -2x. So I'm gonna create my little XY chart. I'm sort of running out of room, so I am going to put it above the 12. So it'll be x is greater than or equal to 2. Again, I'm adding that constraint to help me figure out my numbers that I fill in for the x values. So it's going to be a +2. And then a number that's bigger than 2 would be 3. So this would be -2 times 2, which is -4. And then -2 times 3, which is -6. So now I can plot my points. Remember, the whole process of that gives you an ordered pair. So we have a point at 2 and -1, 2, 3, and 4. And then we have another order pair at 3 and -1, 2, 3, 4, 5, 6. All right, I'm going to connect my dots. Oops, did not connect my dots very well on that one. Connect the dots, add my little arrowhead, and then I am going to, I do have that equal to portion here, so it's going to be a closed dot on the constraint on 2. Okay, and I do want to talk about IXL really fast, just to make sure that you guys have just a little bit of experience. We'll do an example in a minute, but I want to point out that this particular case, I'm going to change my color to yellow. Anytime you have a dot and then an arrowhead, that is called a ray. And then if you just have two dots, this is called a segment. So I do want to point that out. When you have a normal inequality like you have up here with that x is less than or x is greater than, then you're just going to have a ray, and it should be pretty straightforward. But when you have the compound inequality, that's when you have a segment. So I just wanted to point that out. I've had some questions about that today when they were doing homework. All right, so here's our very last one, and this one's pretty special because it is, I guess, famous, if you will. It's a stepwise function. So let's go ahead and do this one. First things first, let's put our constraints. So we have the number -1. Oh wait, we should probably put our coordinate plane first. So this one you can just put right in the center, it doesn't really matter. But here is my coordinate plane. And this one I'm going to graph just slightly differently so that you guys can have like another alternative method to sort of help you. And that's the very first thing I showed you when we drew the whole thing and erased the portion that we didn't need. So I have a constraint at -1. That part stays the same, right? Step 1 is still step 1. And then I have another one at 2. I've had a lot of people today think that the other constraint was at -1, and that's not true. It's at 2 because that's what's in our constraint with the inequalities over here. So I just want to make sure that nobody at home is accidentally thinking that as well. Excuse me. So then I'm going to graph my equation -1. Well, if you think about y equals mx plus b, right? And I'll change my, here we go. So if I think about like y equals mx plus b, if my equation is y equals -1, that's just a flat line at -1. So technically my whole line looks like this, right? And it goes on forever this way and it goes on forever that way. But my constraint says I can only really look at it, or I only really need to draw it if it is less than -1. So I'm going to erase the portions I don't need. And if you're like, well, if I know that I don't need that portion on the right, do I even have to draw it and then erase it? No, obviously, if you know what's going to happen, just draw the portion you need. The other thing is it does say less than or equal to right here. So this is going to be a solid dot on the constraint. Don't forget, it has to be on this dotted line or it's incorrect. All right, and then we have our, wrong color. Then we have our second one, which is 0. This one is a compound inequality, so it's actually going to be in between, right? It's going to be in between the two sections in the center. This one, again, is going to be, and I'll make it a lighter color since it's on the y-axis. Technically, it's on the x-axis, but I don't need all of that. I just need the portion in the center, right? Because that's all I really care about graphing about right now. And this is an open dot, and this is an open dot. So on the -1, I need an open dot, and on the +2, I need an open dot. All right, and then finally, my equation of 1, again, this is representing y equals 1, so like the previous one was y equals 0. So I have y equals -1, which is a straight line all the way across. I'll make it nicer. All the way across. Arrowhead, it goes on forever. But we only care about when it's greater than 2. If this is 2 right here, then this is sort of my cutoff point. This is the only piece I need, which is why it's called a piecewise function. Okay, so I'm going to erase all that, and now I just need to make sure my dot is correct. It is less than or equal to. Remember that equal to phrase is what causes us to have a closed dot. So I'm going to put a closed dot on that line and on the constraint line. And so this is our final answer. And the reason why this one is special is because they look like stair steps, and so sometimes teachers will actually refer to this as a stepwise function. All right, so let's look at IXL really fast. I just want to do one quick example so that you know how to use the controls, because that is the hardest part about using the IXL program. So let me switch over to that. Okay, so here's the IXL program, and we can sort of see that we have our piecewise function here, and we have two compound inequalities. I personally recommend that you add your constraints as a highlighter. You can use that with the options. Oh, it's a little hard to see. Let me try to show you a little bit differently. Over here off to the right hand side, you have this little pencil, and this lets you draw on your screen. That's the hardest part about using IXL. It's not paper, so it's harder to add your like little notes and things like that. So I'm going to use the highlighter tool, and I'm going to highlight the numbers in this constraint. The numbers are -4, it's not pretty, but we're just going to roll with it, and -1. In my next constraint, I wonder if I can change the color. Oh, cool. In my next constraint, I have -1, which I already have, and then I have +8. So I'm just going to go ahead and add that. Now, as I mentioned before, if you have a normal inequality, then you would use array. But in this case, we have a compound inequality. We have two numbers within the same inequality, and so that's going to be a segment. So I should have one point on this constraint and then another point on this constraint, and the same thing for the next section as well. Okay, so now what I'm going to do is I'm just going to do some XY charts, and I am going to do this with the computer, so it's going to be really ugly, and we're not going to talk about it. All right, so for the equation, right, -2x, where it constrains at -4, and if you guys remember your interval notation, this would be from -4 to -1, right, where this is an open dot and this is a closed dot because of that equal to portion or because of that bracket. Oh, so ugly. We're not going to talk about it. Okay, I'm going to create my XY chart. Boom. So bad. Boom. All right, I'm going to choose, and I'm actually going to choose both of these numbers, the -4 and the -1, because it's just going to make my life better. So I'm going to fill these in. -2 times -4 is 8, +8. And then -2 times -1 is a +2. And so I should have a point at -4, 8. So I have my segment already highlighted here. So it's going to be -4, 8. And then I'm going to have -1, +2. Okay, now notice, as I said before, that on the -4 line, it should be an open dot, and I don't have it. So you can actually change that down here with the point fill button. So I'm going to go ahead and click that. So now it's highlighted, and I'm going to click on the point that I would like to change. So now it's, fixed, but let's say I made a mistake. You can just click it again, it fills back in, and then go to the other one. But that's not what I want. So there we go. All right, so I have done all that. Let me erase. Boom, 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 boom. Oh, gosh. Wait, it's just, all righty. Okay, so now I'm going to do the work again, but now I need to fill in this area. So I'm going to be doing the pink highlighted one, and that is going to be 2, right? So I actually can think about this as mx plus b. I don't really have to think about it, which is pretty nice. So I need a segment because I have a compound inequality, and I know no matter what, it's going to be at 2. Now here's where you have to make sure you're careful. You need to make sure that you start on the constraint line. So as you can see, like, my highlighting is not very good, so I almost want to start here on 0. But that's not actually where I'm supposed to be. I'm not supposed to be from 0 to 8. I'm supposed to be from -1 to 8. So let's say I accidentally made a mistake. You can go down to the edit button down here, and you can either change, you can either change the point that you had back to where it needs to be, or you can be like, I just made a mistake, I'm going to erase it. So just like I'm about to erase those lines. Okay, so I erased it, and now it's time for me to extend it. Notice that, like, I'm technically supposed to have this open dot right here, but also on this line I'm supposed to have a closed dot. I don't think it's going to be that big of a deal, but we shall see. I wonder what happens if I press submit. Watch me post this to YouTube and it's wrong. Oh, no, it's right. Okay, so obviously they're not too upset about whenever it intersects like that, where you have the same point has an open and a closed dot. Just fill it in. It's okay. It's going to be all right. All right, so hopefully that helps you guys on your homework. If you have any questions, please make sure you email me or contact me on Remind. or email. I think I already said that. It's fine. I hope you guys have a great weekend. Bye.